That's so cool.
It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
Yes. That's so cool.
It's okay. It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
Yes. It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
Hello, everyone. Yeah, I think we are online, right?
Yes, we're alive.
Yeah, we are live. So, welcome to our Percona meetup. We have our special guest for this meeting. This is the end of the year meeting, so we are going to celebrate that. And for today, we have Charlie Batista, who is the tech lead, Postgres tech lead in Percona. So glad to have you, Charlie, here.
Yeah, thanks everybody. It's been an amazing year, right? So we are coming to the end of the year, and we had many sessions, right? We talking about a lot of things. We talked about replication, high availability, proxy, caching. It's been quite exciting, and I hope we've been helping people out there to get on board on this amazing world that is Postgres, right? So we always try to bring some different topics, something that can be useful during the day life of a DBA. And today's topic, the idea is to talk about troubleshooting, right? Especially query troubleshooting, right? Who never had a performance issue, who never had a query that was running this slow and those things, right? And the idea today is to talk about those things. We also have Jobin here. Hey, Jobin, how you doing? Can you hear me? We also have Usama.
Yeah,
Yeah, we
welcome.
have Osama. Hey, Osama.
Hello.
Nice to have you here.
Yeah, same here, and very very excited. Like this is the last of this year, I guess. So very excited about the start.
Yeah. We should do more discussions like the one today, right? To make things more interesting because the last ones that we've been streaming here was more like a monologue, and today we have more people. So, right? And it's quite interesting. And actually, I have a challenge for you guys. Let me share my screen here because I kind of have a challenge for you guys. Uh, where is my screen? Okay. So you can see my screen, right?
I
Not
think
still no,
No?
no.
Oh, really? Oh, interesting.
I don't know if it's only me or like, but I can't see it.
yeah, Mario is also here. Maybe Mario could tell
Yeah,
us.
you must enable the screen sharing. It would appear similar to when you add someone. You must enable.
Yeah. You already shared, right? Yeah, Charlie?
Yes, I'm already sharing my screen, exactly.
So, share screen. But I'm going to share mine.
Okay,
So,
let
try
me.
again, please.
Okay, stop it sharing. Let me try to share again. Here, share screen. Okay, and I'm sharing now.
To activate something, Mario, here? Because I don't see the option to activate it.
Yeah, you should see the screen on the left of red stream, and you must
Okay,
enable the screen for us to see.
we're having a technical difficulty here, guys. Hold
Controls.
tight. That the screen gonna it will come
Yeah,
eventually.
yeah. Let's start with troubleshooting the session. Then we'll
Yeah, it's a
Yeah.
troubleshooting session, right? Uh,
Okay,
all
now I think.
right, now we got it. Let me see
yeah.
if I
Yeah.
can
Okay, we use
There.
your
improve.
tips. We use your tips for troubleshooting, so we have it. Go ahead.
Okay, can you can you guys see it properly, or it's too
Yeah,
small?
yeah, I can see the terminal.
Okay,
Though the text
and
is
it's
small.
not small, right?
Uh,
With the font size.
yeah, let me put on the glasses.
Could you type something? Could you type something to see?
Yeah, let me type something.
I think it's good,
Yeah,
right,
it's
Mario?
readable.
Okay, yeah, looks good, looks good. Nice, nice. So, what is the problem that I have for you guys today? So, today we have two tables here that I'm most interested in this database. We're going to pay attention on this table meta and this table meta object. They're quite simple tables. So, let me describe the table meta. Looks like I have a problem. Oh, sorry, I'm using an old version of the PSQL. Here,
Could you, Charlie, could you zoom a little bit more, please? Licio, say that if you can zoom a little bit more, please. Yes, thank you so much.
okay, it's better now, right? Okay, so, all right. So this is the table method. I basically have three columns here: the ID, the parent, and the name, right? So it's pretty simple, and in fact, it doesn't have even much rows here. If we select here, we have 20 rows. Small table, just three columns and 20 rows. So whatever select that we do here, let me enable timing here. So if I do a select start from meta, it should be quite fast, right? Because, well, it's just a small table. But we have another table. We have this one here. So if I check this one, it's also a very small table. It's not a large table. As we see, we have the ID of this table here. We have the ID of the table meta. So the table meta is the parent of this table. We have the name and we have some data, JSON. Well, first things what I like to do is to sort of draw a diagram of my database when I'm trying to troubleshoot, right? And actually, I have it here. Let me share my oops, the buttons. Okay, now I have the buttons to share back. So I have it here. What is this? Okay. So you can see this diagram, right? So as you see in this diagram here, my database is very simple. Again, two tables. I have the table meta that has a self-reference and the table object. It's like a queue of objects, right? So the parent can have subqueues, and those subqueues, they have the objects, the elements actually inside of those subqueues. And we have one select. Let me go back to the terminal. Keep that in mind. Keep that one in mind, because we have, okay, sharing again the terminal. So we have this nice select here. Let me get my nice select here. What is my select? Great. Okay. All right. Copy and paste. Don't get afraid with the select because it looks a lot larger and actually has a syntax error. Yeah. And the syntax error, well, it was on my copy and paste. Interesting. Let me copy and paste again. Just give me a second. I will copy, okay. Just copy, okay, and paste, and should, okay, mouse work. So I have this select. It looks complex, but don't get afraid because of the size of the select. What matters is the result. And as you can see here, it's pretty slow. right? It's very slow. It will finish eventually. Okay, it took 21 seconds to finish. And this is just a report. So we have the ID of the elements, the meta, as you can see here. My meta object ID1, the name is meta1. It has 0 items in the queue because it's the parent. So the application does not allow the parent to put anything inside of the queue, only the children. But as we can see here, the children can have children's. So those are grandchildren, right? So we have the grandparent, the parent, and the children here of this object, for example. And this is what that select does. But the problem is the customer is complaining that it's taking 21 seconds to execute the select, and they run the select a lot of times during the day. So if you try to run it again, it would again take 21 seconds. So even caching here on my database is not working, and caching was the topic of last session, right? So my question for you guys, including you, Salman, Jabin, everybody here, how I can improve the performance of the select? What will you guys do as the first step to start troubleshooting the problem here? Anybody?
So for a start, I would open the code and, and try to implement hierarchical queries syntax in the code.
So you would solve the problem in the application, not in the select. Is that what you mean?
in the Postgres server rather.
Okay.
So this we can we from I don't know the query exactly, but I think something like CTE or like the intermediate results like intermediate table could be helpful in this case. Well, that's just a wild guess.
Okay, that's fine. So I'm taking notes of the options. An intermediate table. But the problem about an intermediate table is we need to change the logic on the application, right? The logic on the application.
By intermediate table, I mean something like CTE queries.
Okay.
Yeah.
But this one uses one already.
It is also because I can't see the query. That's why I.
Okay.
Yeah.
Can I post here? Let me try to post the query in the. I see people commenting. Let me try to open the YouTube. I think we are on YouTube, right? Let me try to open YouTube here and post the query.
There is no in YouTube. There is no questions.
Yeah, but I just want to post the query on the YouTube.
Okay.
Okay, let me just open here my YouTube. That's gonna be interesting because I'm probably gonna hear myself. And it's always awkward when you hear yourself, or at least for me. Oh, I opened, okay, YouTube link here. Just give me a second. I'll try to, okay, say something, Charlie. Well, it will break the format. And it won't let me post because it's 200 characters max. And it has 1,000 characters on my select. Are you gonna do something better? I have a GitHub. So I'm gonna post on the GitHub. So on YouTube, I post a comment there that is the GitHub page. So if you guys open this page here that I just posted on YouTube, you see, you get the query there. So the last query is the one that I'm executing here, right? So let me say now what I would do. So as I mentioned, first thing usually that I do is to draw a diagram of the database, right? So luckily this one is a very simplistic one. So I'm gonna use paper and pen, and I draw here my paper and pen, and I'm gonna draw a diagram here that I have the table meta. This table meta has the ID and has parent. This for now is what it's interested. And then we have another table that is table called object. Has ID and also has parent. And this table here has a self-reference. So this is, you guys see, let me hide my face here. Okay, let me just stop share for a second. So you guys can see here, right? I just stopped sharing. So this is usually the first step that I do. So, and then let me go back to my window. One thing that I also do is check what are the indexes we have there. So if I check here my table meta, I'll see that I have a primary key. We have a primary key here, and that's it. I don't have any more index. I have constraints here, but constraints, they are not indexes. So I only have the primary key on this table meta. Okay, if I check the meta object, I'll see that I also only have the primary key. Well, that's the first problem that I see. Like, I don't have a key on the columns that we might be using. So, and that looks like a problem for me. I cannot tell if it is really a problem because, well, I only see on the tables, but it looks like to be a problem, right? And how can I be sure if it's a problem or if it's not a problem? What can I do to check if adding an index could help in this query without adding an index? Because if I add an index here, it's gonna take time, depends on the application. The application gonna suffer performance issues and all this kind of stuff. What can I do to check this thing here if adding an index would be interesting? Guesses? Guys? Nope, nobody. Joby, I cannot. Oh, I can hear you.
Okay.
Okay, now I can hear you. Nice.
Yeah. So let's explain that query and see what happens.
Good. Let's explain the query. So my database here, it's messing up. Let me open a editor here. Just to, because it's messing up here with when I paste the query here. I'm gonna. Okay, the only thing that I did was to add the explain, right? And I'm gonna run here. See, I just added the explain, and the query is basically the same. So, okay, we have an unexplain here. I'll try to. Okay, this is what we got from the explain. My goodness, but it's going on with my terminal here. It's not helping much. My configuration, it's is having problems here. So what my explain says here is that we have a CT, right? We have a CT here named meta hierarchy. This CT does a recursive union, does a sequential scan that has a subquery sequential scan inside, and then it has a hash join, all this kind of stuff. But how can I start interpreting this information here? Let me try to make it better. Okay, this is all. How can I start interpreting this information here? How does it work? I think it's a very important thing, right? When we want to use whatever tool that we use, we need to understand how the tool works, right? And an explain on any database, including Postgres, is a very powerful tool. And understand how to extract information from an explain is very important. And one interesting thing on the explain on Postgres is that it's not top down. It doesn't start on top, just like I was reading, or it's not down top. Actually, the indentation here tell us what are executed first, right? So the things that are more to the right are the ones that are executed first. And sometimes you can have two things executed in parallel. Postgres has the ability to make operations in parallel. For example, seems that those operations here, they've been executed in parallel, right? So we have a sequential scan on the table meta object. And this is a very important thing. Sequential scan, it's usually an expensive operation. We usually do not want to do a sequential scan. What is a sequential scan? Sequential scan is when it reads the table, the whole table from the beginning to end, right? And how can we prevent the sequential scan, Jobin?
We can force or turn off the sequence, enable sequence scan off and try whether the alternate plan is better or not.
That was a bit confusing to me. Can you explain a bit more?
We can have a session level setting. Set enable where are you typing?
I think it's like enable seek underline seek underline scan, right? So we can disable the sequential scan, right? We can put it to false.
Yeah. SCQ scan single word, no underscore.
Oh, okay. Okay, we disable the sequential scan for this session, right?
Yeah.
Well, even if it was not for this session. So let's try to do an explain again. Okay. The sequential scan.
Yeah, it's unavoidable.
If what is the other option that the database has? If the database doesn't do a sequential scan, what is the other option for the database to run? It should use an index, right?
Yeah, so I think we should give an option to the planner to have two scans, and based on the cost, it can select the better one. So right now, without an index, I think the sequential scan is the only option. So even if we disable it, that's not gonna solve it.
Good point. Good point. Remember that what I said? We have no indexes here. And look, the key that is using in this object is meta underline ID, right? And it's doing a sequential scan here, right? To join those. So as you mentioned, Osama, probably if we create an index on this this key here that's been used to sort, we might improve things, right? So let's try to create this index. Create index. I'm just gonna give it a name, IDX. I call the table name and the column name. This is the table, and this is the column. Here we go. Okay, it's taking some time because you see, one thing that I didn't do, I didn't show you guys how many objects, how many rows we have in this table. Remember, I only showed the first table, and that was on purpose because this is the largest table that we have here. Let me do a select count from this table. So see, this table is large. We have here we have 10 million rows here in this table. So this is the table it's causing all the problems, right? All the troubles is here, and that's why our explain here shows us. And now look what happened here. It's using an index scan. We have a change, right? We have a change. We didn't check anything else. We only checked the first one here, and this is change. Already changed something. It's using an index scan. Let's change that parameter back to the default, just to see if the explain. It will probably still. Oops. Let me explain here. Okay. Yeah. See, even with that parameter on, now the database believes this is cheaper to use the index, right? But one thing that I would like to point here is the explain that we are using here, this just explain, it's an estimation, right? So it doesn't necessarily means that this is what will happen, but the database is telling you, the optimizer is telling you, look, I'm checking the data that I have there on the statistics, and based on the statistics that I have, I believe this is the best way to run your query. This is what the database is telling us. I believe this is the best way to run your query. But it doesn't say, if I look, I'm going to run exactly this way. Things can change during the execution because the database can figure out something is not as intended, and so things might change. But having something already changed here, it gives a hope. So let's give it a try. Let me copy, let me just, okay, I just execute this one here and I'll remove the explain. And let's see how long that's gonna take. Here we go, here we go. Well, looks like it didn't help much, right? Well, it's 16 seconds. So if we go back here from the last execution when we had already this query in cache, let's go back. It was around 17 seconds, right? Oops, I lost the history here. But it was around 17 seconds, from 20 to 17 seconds just because of the cache. So it dropped from 17 to 16 seconds. It doesn't mean, it doesn't look like much better, right? So the index might have improved a little bit. Let me just execute again. But it doesn't seem to be that efficient. I'm gonna even do one thing here. I'm gonna run a vacuum analyze on that table to try to update the statistics. It shouldn't be needed, but just in case. So let me run here. it will analyze, update the statistics, and then everything. So let me run again, and we'll see. See, it's around 16 to 15 seconds. It's pretty consistent. It's taking the same. Okay, that was the first attempt of optimization. We created the index, and well, it's still pretty slow. If I send to my customer this, right, they're gonna complain about like, look, yeah, you drop it from 17 to 6 to 15 seconds. So didn't help much. What next we can do? We can keep going to the explain, right? Let's go back to that explain. So looking here at the explain, what can we do there to improve here?
So I believe we could look at the operations which are causing which have the highest costs. So that's the operations we want to like optimize first.
Good point. That's a really very good point. Look, going back here, it's from what is from the right to the left, right? So here it's doing creating the CTE here, but they don't see anything expensive. So the creating the CTE here doing the scan to create doesn't seem to be anything expensive. If we go here on this top branch, let's put this way, we have two branches, this first branch and the second branch. They run in parallel. If we go to this top branch here, doesn't seem to be pretty cheap, right? The operations here are pretty cheap. So probably what's causing the expensive, look, the cost that we have here is the second branch. Okay, let's go. This first operation here that's doing the scan. It's using the index, it's fine. The cost starts to increase in here. Look, even you using the index, it's an expensive operation because we have 10 million rows, right? So it's searching all the rows because of the query. As you saw, we don't have any workloads on the query, so it needs to read all the rows. And just to scan in the index, the cost is already high. And then it's doing a merge right join here. And when it does the merge right join here, the cost is skyrocket. See? It goes for around 600,000 to 6 million of cost. It's skyrocket exponentially. So looks like this operation here is the one that's causing the problem. Can we get extra information from those things, or is this all the information that we get from Postgres? Can we
Explain, analyze with the.
Yeah, we can do better, right? We can do an explain, analyze. Good point. Explain, analyze. We can also check the buffers, right, to see if we have any buffers or anything related, right? And we can ask the database to be verbose. So whatever you know, database, tell us. But let's explain people what this analyze here, those things do. So the analyze, it will actually run the query, right? And this is important to know because if I had, for example, a drop table or an update or an insert here, we want to first start a transaction, right? Because right now we are not running on transactions. So if I do an explain and analyze in a delete, it will actually execute the delete in the database. If I do an explain and analyze in a drop table, it will actually drop that table, right? The explain and analyze runs the query on the database and then collects all the information during the execution time, during the time the query is running. And if anything here interferes or destroys or do anything with the data, we definitely need to start a session, right? So then after the explain, we do a rollback. That's not our case. So our explain is just a select. It doesn't do anything, but it's always a good practice to have here to put this in a transaction, right? So it doesn't hurt. I'll run here as example and see it's taking a lot more time now to execute the query because it's really executing the query. It's collecting the data, it's pulling everything, so it will take more than the 15 seconds that it took before. Because all this instrumentation and all those kind of things, it takes time, CPU time, it takes memory and all the things from the database. So let's wait a little bit. And Jobin, out of curiosity, does it happen too often in support to help customer troubleshooting queries performance?
Not too frequently, but yeah, there are cases where common patterns. So why queries will messed up. So one is the developer tendency to copy paste instead of writing from scratch the tables and joining them. They'll be copying some of the subqueries and putting into another query. So end of the day, they'll get a very big query. And another common problem is excessive use of views. So all the complexities will be hiding behind.
Inside a user view, right? Yeah, I've seen those. So you have just a tiny query, but instead of having one table, you have a view of 1,000 instructions, right?
Yeah.
I've seen that one. And Usama, you know what would be nice from one of our streams to do an overview inside of database, to do a debug to see where are the points that the query passed by inside of the code in the database. It's quite interesting, right? So it gives people a different view of approach on how the database works internally. I put in
Yeah,
that note. That would be a nice one. I'm
yeah,
gonna invite you to do such a session.
sure. I'm up for it.
Nice. All right, we got it here. So let me just go to the end. See, we have a lot more information here. Okay. And let's try to organize. We have the first branch here. The first branch, again, this first branch doesn't seem to be anything expensive. See, the final cost of the branch here is 477. It's okay. We can ignore that for now. But the second branch is still that very expensive cost, right? So it's really high.
Yeah,
And
sorry to cut to further explain, analyze. You can actually see the actual time taken for this particular operation. So rather than cost, we can jump to the actual time as well.
That's another good point. That's a really good point. And another interesting point that we can see are the buffers, right? If we're keeping that in memory in buffer, or if we're going to the disk too often. And looks like we're hitting the buffers here, right? So it doesn't seem to be a problem of just specific disk IO. See? And the thing you mentioned is, yes, it's a good point. We have the time here. Look, the time, mostly of the time was taken here. We can see from 0, blah, 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 35 to 16 million milliseconds, 16 seconds, right? It was just one loop here, one operation. And this is one thing that we need to pay attention, because sometimes I don't have it, I don't see it here. Sometimes we see one operation, let's say we see this sort operation here, and it takes like just a few milliseconds, and then the next operation on top takes seconds, and it doesn't make sense, right? So you have one here, and the next one that's supposedly just to be the add-in time from the previous one plus its own time. If you sum the time, it doesn't make any sense. And the thing is, the database might do iterations of the same operation. For example, in this case here, this index scan, it only needed one loop, one iteration to collect all the data. So all the data was collected in one iteration. It went there to the disk, whatever it needs to go, did everything it needed to do, one operation. Sometimes it needs to do 2, 3, 4, 10, many operations. And the time that we see here is the time and the cost of one of that operation. So we need to multiply the amount of time or the amount of the cost that we have here by the how many loops it did in that iteration to finish the job here. In our case, it's just one. And we can clearly see here. See, it's 11 seconds here. And, oh, this one it was very cheap, so this is not a problem. This one is actually started to be a problem, right? And in this query, this specific query here, every time that I look at those things, I always see that the amount of data that's being collected is the problem. It's actually the problem here. And we added an index, and it didn't help much because we're still collecting like 10 million rows. We still need to get all those 10 million objects to put here. We need to join. See, this is the problematic thing here. The join here. This join uses the index that we had to do the join. And this join with 10 million rows here, it's been the problem. And I don't see any way that we can add more index or anything that we can optimize here. Do you guys see anything?
I don't know, maybe we could try to convert this index scan into an index-only scan, maybe? Because the index scan at the end is doing two access, right? To the index and to the heap. And the index-only scan could retrieve all the data from the index itself with not the second access to the heap. But at the end, it's a lot of data, so I don't know if this is gonna be better or not at the end.
Yeah, well, welcome on board, David. Nice to have you here. And that's a good point. That's a really good point. How can we do an index-only scan here?
Yeah, as we can see here from the output of the explain, we see the output line, right? So all what we are getting from the index are those columns, the object ID, meta ID, object name, and object data. So we can include those columns in the index definition with the include clause, and that is gonna add the
Let's
data
first
to the
check the meta object. Right, we have the object ID. Oops, we have the, where is it? Yeah, we have from the same table, object ID, met ID, name and data.
Yeah.
That's
All
the
the four
whole,
columns.
yes, that's the whole table.
All the 4 columns, yeah. Okay. Yeah, well, that maybe make no too much sense because we are going to end
Put all of them. Yeah, but that's a good point that you put all there. Like, let's say, for example, if we can find a way to do not collect those columns here, right? Let's say we only need two columns from our select. We don't need the other ones. yeah, we could create an index with only those columns, and the PostgreSQL, it go only to the index and extract the information from the index only. It doesn't need to go to the table. That's the heap, right? It doesn't need to go to the table and to select. And usually that's really fast. That's very fast, because especially if we have, like, let's say, a table with 20, 30 columns, right? So it's a lot more expensive to go to the table if we could go only to the index. That's a really good point. Well, it doesn't solve our problem here because our table is, it's quite small, right? So it doesn't apply for this example, but that's a really good point. And thanks for reminding that one. I was missing that point.
You're welcome.
Yeah. Anything else, guys? Can we look? I see the problems because we have too many rows, right? Too many objects. 10 millions. We always go to those 10 millions and think, can we make those in parallel? Like, can we force a database to do something in parallel? And maybe let me go back to the select. Let's try to simplify that select a little bit, right? So let me remove the comments. So it will make things a bit simpler. And just, okay, instead of doing here, let me share actually the order. What is the sharing thing? Let me stop sharing here. And I will share where I'm editing the select. What is it? Okay, I can't find. Okay, yeah. So you can see my Visual Studio here, right?
Yes.
I just need to improve the font size. Just a second, I will do that. Just settings, font size. I think 18 is it good? Can you read it well?
You can zoom it a little bit more.
Sure.
Would be great.
Right, it's 22. How
It's
about
better.
that? Okay,
Yeah.
nice. So yeah, it's good because here we can edit things, right, and make it simpler. Okay, this is our select. This is our select that we are executing there. I just removed the comments. So how does it work here? We have a recursion here, right? So we have this main select. This is the main select. I can do one nice thing here. I can run my terminal. Let me just increase the font size of the terminal. Okay. No, I never remember how to increase the font size of the terminal. Here, usually more to the end. Okay. Okay, so the nice thing here with Visual Studio Code is because I can just run the terminal here, and we can execute the select here. Well, this is my first select. What my first select does is to get all the parents, right? It's just get all the parents. If you see here, my select, which meta parent is new. Those are the real parents. The ID 1, 2, 3. So they don't have any parent, right? They are the grand parents, the top of hierarchy, right? So I get this select here, and then this recursive will loop through this select and execute the second select. For example, it will just let me copy this select here just to give an example. Okay. Actually copy everything. So what it's gonna do is to run this select. So for meta, this meta hierarchy is the name that I gave here, right? That's just the result of the select. We can just get this select here. And do a subjoin. I hope that works. Let's see now. Oops, I need to finish with this thing here. Okay, MS actually. That's the name alias that I gave. Okay, see, it will start building the things. It will get the parent and then we select to get the children of that one. And then it will get those here and the next iteration, the next loop, it will get the children's, the grandchildren's and the so as many we have here in the hierarchy, it will just show one of another, right? And then I just join by the end with the last ones to get everything and do the order by. So the secret here of is this guy, and that we are looping, using this one to loop inside of the second select. Basically, this is what the recursion do. And it's super nice because we're creating a loop. It's just like a while or a for loop inside of a select, right? It's the concept of CTs and using those things, those recursive query. It's quite interesting. It's super cool. Well, at least I think it's super cool because we can do a loop here without any programming language. But look, we still didn't solve the problem, right? We still didn't solve the thing about the problem about the number of rows. What if instead I do this select here outside? Remember that we select all the, here what it does, it selects all the parents and the children here. And after select all the parents and children, we still have another left join. Where is our MO and ID? It's the joins here. See, the joins outside. What happens if instead of those things, I actually do something a little bit different? Like, for example, I have here another CTE, let's say object. Do a select meta ID, because this is the only thing we need. I count as it popped from meta object. Group by meta ID. So what I'm doing here is I'm asking the database to count all the objects that we have. Remember those 10 million rows? Instead of I join the 10 million rows first and count later, I'm trying to count first and then join later, right? Now I have QCTs. Looks even more complicated, right? I'll keep those one here. And this, I'm gonna do another select because I want to join the two CTs that I have. The CT1, I'm gonna get the meta ID because this is the parent that we have. I also want the hierarchy ID and the name, obviously, hierarchy name, because I want to put all of them. I'm gonna coalesce here the total, because if it's null, I want you to show 0. Total. And my from gonna be from the two CTs, right? CTE. How I call up there is CT. Actually, it's meta hierarchy. And I'm calling this one C1. And I'm gonna do a left alter join with ECT here. And I call it O on C1 dot IT pose O dot meta ID. And I don't need this group by. And here I call actually this C1 and this C1. Okay, looks cool, right? Does it work? Does it even run? So let's try to see. So the recap here is what I did is when I saw the explain, the analyze, all the time it was showing me that the biggest problem was the join, because it was join 10 million rows, right? So here we need to count the number of objects that we have in each queue. Instead of join first and counting later, what I'm trying to do is I'm counting first and then join later to see if that's gonna help anything. Obviously, I have a problem here. CT.
Two selects one after.
Select.
Oh, thank you guys.
Yeah.
And voila, we have the same result. Let's time it. And it took less than a second. See, this is exactly the same result that we had there. With the same order by exactly the same thing. But we drop it from 15, 17 seconds to less than a second without changing anything. Because those 17 seconds, we already had created the index, right? So, and the thing we did here, we used the explain. Let me go back here to the explain. Where is my... I always fight with this tool. Not this one, I think it's okay. So let's go back here to the explain. So this is that first explain. So the explain help us to understand that this join here, see this mesh right join that was caused by this join outside here, this last join here, was the biggest problem. So we needed to find a way to optimize this join. This join here, it takes all the 10 million rows, as the explain says, mentions here, we go 9, blah, blah, blah. So all the 10 million rows, do one loop in one thread only, and takes almost all the times. In this example here, it takes 16 seconds. The idea was, let's try to parallelize this operation. Let's try to make it smarter. So instead of joining with the 10 million rows, let's try to get the 10 million rows and do the sum, because see, the count is done outside here. This is where the count is done here. Let's do the count first, and then when we get the result of the count, what we do, we join with the CTE that creates the hierarchy. But now we do not have 10 million objects anymore. We have a lot less. Probably like we have 20, 30, I don't recall how many objects we have. And let's explain that select. The new select here. Let me copy the new select here.
This one that you are showing us is the first one, right?
Yeah, it's the first one, exactly. So let's do an explain analyze. Let me just create and verbose. Let me put here. Let me explain this one here. It will take some time. Actually, the explain usually takes a lot more time than the query execution itself. Remember, this query executes in milliseconds, less than a second. Yes. But the explain took a lot more time, right? And let's see what was the magic here. The magic, look, it does, let's go, yeah, this is the expensive one. Exactly, this is expensive branch, yeah. See, this is when you start the expensive branch. Let's go down here, go down, go down. Oh, now we see something different here. Now we see workers. And we see a parallel index-only scanning. See, David, we were able to do an index-only scan, changing that the CT.
That is great.
It is, right? It is great, because so it did, and it did in parallel. And in my configuration, I only have 2 workers. I could have like more because I have 16 CPU cores here on this box. But anyways, on the configuration, I only have 2 workers and doing the work in parallel. See, the cost here is a lot less, is smaller, because it's doing an index-only scan. Even if we sum up the cost here, that is around 11 to 12,000. It's a lot less than the 5 to 600,000 that we had the other one to do the full index scanning and everything, right? And then when it goes to do the counting and everything, it also does the parallel. So the only thing we needed to do here is the approach of the select, right? We tried an index, it didn't work. We tried to force using an index, it didn't work. We thought about doing the index only scan, but like initially we didn't have that option because we used all the rows, the columns, all the columns here. So if we create an index with all the columns of the table, we just leave the table alone, right? We don't need an index with all of those things. But changing the approach here, instead of doing the join first, but going there and doing the counting first, and after the whole counting, applying the join made the whole difference. So in this optimization, without changing the configuration, hardware, anything, we just made the select 15 times faster, at least 15 times faster. How much money do you need to spend on Google Cloud, Amazon Cloud, whatever cloud, to make your hardware 15 times faster? It's a lot of money, right?
All what you have.
It's a lot of money. So we didn't only help the customer here on making the application faster. We also help the customer here to save money. And this is an example of the power of query optimization that a lot of people, a lot of DBAs out there, when we talk about query optimization, it doesn't work. It doesn't worth the effort. You know, well, what's the gain? So it's like just to give it 30, 40% improvement on the query. Well, we can make it like 15, 20, 30 times faster. And it would be super expensive if we do this improvement using Hacker and other things like this. Yes, do you guys have any comments, thoughts?
Really great talk and demonstration, Charlie. We appreciate your time and your support for this. So I have one question.
Yes.
So we can say that it is a good practice to optimize first the query, to write the query and optimize it at the beginning, right? Then doing after.
Sorry, I lost the first part when you started saying it cut a little bit. Could you repeat that again?
Yes. Could you hear me well?
Yeah, no, I can hear you well now.
I'm asking if it's a good practice to optimize the query while I am writing it in the same time at the beginning of everything.
No, I don't think so. I don't think so. And the approach that I take is make things work first, right? Make it work slowly, whatever. Make it work as fast as you can. When it's working, when it's getting the data that you need, you have a baseline. Okay, it's working. Like the first one was working, it was getting the data, it was solving the problem. Okay, but it was too slow, right? So from that baseline, we can start the optimization. If you start trying to optimize the query before even you get it running or anything, everything gonna be guesses. You're gonna guess, oh, if I create, just like index creating, it's a really bad practice to, when you're designing your database, you put index everywhere, right? It's really bad practice because index, they are not for free. And actually, they are not cheap. Every time that you write on the database that you're doing sort, or not update, or not delete, the index, they need to be updated, and it's expensive. So pre-optimization, most of the times, is not a good practice. So make things work. Okay, I'm designing my database. I created those tables. So obviously, you're gonna put your primary keys. So you're gonna put your reference like the foreign keys, but like foreign keys, they are not indexes. They're just references. You don't need to give index to all of them. Some foreign keys you can ignore. Like in our example here, the index was just obsolete. So we can go, for this query here, we can go and remove that index. It won't make much of a difference. Right?
Yeah,
Thank you.
Yes, Jabin?
Yeah, one common problem with the development practices is they will be developing with some, say, 100 records, and the original query will be running very fast. It takes milliseconds.
Yeah.
And they won't realize the problem until the records increases to 1,000, 10,000, million.
Exactly.
So the bad query degrades over a time heavily. So its degradation is exponential as the number of records increases. So in last 20 years, this is one of the most frequently asked questions by most of the developers when they joined the call. It was working earlier. Suddenly, what happened?
Yeah, it was working so well before. Like
We
last
hadn't, we
week,
hadn't
just last week, last
interrupted.
Friday was working
It
super
was working.
well,
It was
and
working.
today
And
it's super slow.
what happened? What happened? So the aging is something which we need to account. So the same
Exactly.
code, the same SQL degrades over a period of time. It's just like a human's aging. The more fat we accumulate,
You get slower, right? Yeah.
it's a degrades. Yeah.
Exactly. And yeah, this is a good point. It's a very good point because sometimes your application is working for 10 years. No problem at all. Everything is fast. And then out of nowhere, no hardware change, no code change, nothing has changed. Nothing has changed. It's boom, explodes and become super slow. You reach the limit, right? So that design has a limit. The application is aging. And sometimes it's even the data distribution changes. Like you access the table always, most of the times, the very same thousand rows, and then the table is increasing, and suddenly, instead of getting always the same few thousand rows, now you need to get million rows because the data just shifted. The distribution just changed. And that happens, right? And it's quite common. And this is a problem that's really hard to troubleshoot, really hard to find, because of my goodness. So the query is the same, the parameters are the same, the data similar. Like I still have 10 million rows, but now instead of 10 million rows from state A or state B, and we have all shifted all over the states, and now we need to join a lot of things and collect all, just because the data changed, the distribution of the data statistically changed, your query explodes. And this is one of the most complex and difficult situations we get when troubleshooting performance issues. When like nothing changes, everything is the same, even the number of rows, it's sort of the same, and things explode like this. Yeah.
Nice. Matt,
And
David, Jovin, maybe you have Mario last thoughts, last thinking.
I just asked you. Thank you, Charlie, for the chat. Was very interesting to see your skills doing this process to optimize the query. Definitely is a good example of how the things should be done. And also, I totally agree with the idea that you should try to reduce the size of the data set before joining, because definitely it's a good path to do that. And I have seen a couple of scenarios with that situation where, for example, the query is doing a large list of joins, one after the other, and you end with a huge list of joins. And at the
yeah,
end, you have a huge list of where something equal to this, where something major to this, something that I have seen that works well is to move the where part or the filtering part of the query within the join clause, because you put the join on the column equals to, and the other column where we are filtering equals to the value that you want. So instead of joining all the data set and then filtering just what you want, filter from the beginning when you are doing the join. And that also is a good way to improve this kind of situation and reduce the size of the data set to join.
Yeah, but
yeah,
be careful about that. There are cases where that produces different result.
yeah.
Okay, yeah. That is
Be
true.
careful.
That is
Yeah, yeah, be
that is
careful about that. Yeah, it's a good idea, but yeah.
And there are two cases actually that I see when this happens, because the join, the condition of the join, you can explicitly put them on the join clause, or you can put on the where clause, right? So the optimizer is smart enough, when they get this, they identify that's a join and put the clause there. So usually people coming from Oracle or other databases, they have this as very common practice to not use the join expression. They just put table, comma table, and then on the word that they put all the join there. So this is one thing. But also there is the technique that you can isolate the joins first, like force the database to do the join, or force, in our case, we just use one of those techniques, that there are more than one, there's more than one. We just used one technique that we forced the database to do the operation we want. In this example was the counting. And after them to do the join, right? And yeah, the only concern is what Jobin mentioned, that if we are not careful enough, we can change the results of the previous query. But one thing is, sometimes changing the result is not a bad thing. Sometimes the old query is wrong, you know? So we need to analyze, we need to understand the problem, what we're trying to solve. We need to understand what is the data we want to see. To first identify, okay, is the old query accurate, if it's correct? Yeah, if it's correct, then okay, yeah, we're gonna just try to optimize. But sometimes the old query actually is doing wrong. And this new one with the different results, right? It's fixing the things. But yeah, it can happen. And there are many different techniques to do those things. This one using CTE is one of them. One thing that I like with like CTE and window functions, for example, is because using window functions or CTE, you can isolate the operation, right? We can just start the operation. Let's say I do a count, it was sum, or you can do only that operation first, and then join with those the other things. This is possible. This is a possibility. So, but yeah, we need to understand the problem, the original query, to make sure we're not changing the result.
Yeah.
Yeah.
We don't have more questions on YouTube or LinkedIn. So,
All right, that
thank
was
you so
great.
much.
It's nice to have you, all of you here. You know, it's not having just a monologue, but having interaction. It's so much better, so much better. I hope I can have you guys here during the next sessions, so we all learn with all those things. Thanks, guys. Thanks you watching us. It was another long session, so I was trying to make it faster, but yeah, it was not fast enough. But it was great. I hope you guys enjoyed. Have a great
Yeah,
one.
that's great. Thank you so much for being here.
Thank you.
Bye.
Thank you.
Thank you, guys. Thank you, Charlie, Edith, Mario. Nice to see you guys. Bye.
Thank you.